Hello, everyone. My name is Shashank, and I'm a senior technical program manager here at Harness, responsible for driving chaos engineering. In today's tutorial session, we'll be talking about network experiments. We'll be touching on network loss, network latency, and also the API experiments and the different use cases. We'll go through a sample UX design just to explain the concept before we start going and creating those templates. Now, with that, let me quickly share my screen. Now, before I go into the experiments, I have this sample application here where you can see that there is a Kubernetes cluster, there is a front-end service, and which talks to the payment service. There could be multiple services as well. Plus, the front-end service also talks with the encryption service, which is a third-party service, as you can see, right, which is not present in your Kubernetes cluster. It is outside, and there is a downstream API call that is happening over HTTP or HTTPS. And the service also talks with a promotion service as well, which is again a downstream API, and it's an egress call. Right. So we'll be talking about like how we can target different scenarios. So first, let's assume now since front end is talking to a payment service. Now, if I would like to drop the network packet from front end to the payment service and see how my application behave, what kind of experiment that we can use? Okay. So we will go to the account settings and Chaos Hub, because first view I'm gonna explain for the admins so that this will help them in creating these templates, and then we'll talk about how users can consume those templates. I go to the experiment templates, um, and now let me create a simple template for network loss. Now, when I create a template for network loss in Harness, there are multiple options to do network loss. So the first option is pod network loss. The pod network loss experiment actually always blocks the egress traffic, right? So if you want to target an ingress here, there is no option to do that, right? Pod network loss always blocks the egress traffic. So now as a user, I'll fix the deployment namespace. I'll make it as runtime input so that user can change based on their requirement. And then for the tune fault, the best parameter for a chaos duration for these kind of experiment is somewhere around 180 to 240 seconds. So let's put 200 seconds for now. Network packet loss percentage is by default 100. Now pod affected percentage, you can change it to 100 to make sure that you are dropping all the traffic. Now, if you don't want to do or drop all the traffic, you can make this as runtime input, so users can change it to 25% or 50%. But by default, the best practice here is just drop all the traffic just to see how things work. Now, as you can see that there are further more parameters. Network interface by default is ETH0, so we don't have to worry. Now, there are the parameters called destination IP or destination host, right? So what does it mean? Now, what does it mean here is if you do not provide these parameters, the experiment will work fine. But what it will do, if I go to the my UX design, if I do not provide any destination host, whether it is a third party or it is a promotion or it is a payment, then it will block all the traffic from this front end. So this becomes a black hole scenario, right? So you can always test a black hole scenario without providing destination host or destination IP. But let's say I only want to drop traffic from front end to the payment service, right? So if I drop the traffic from payment service, I can provide the host name. Now, since it is a Kubernetes, I'll just go and in Kubernetes, we have to provide fully qualified domain name, right? This is a so if I go here, as you can see that service name dot namespace dot svc cluster domain example. So something like that you can provide. So that becomes a fully qualified domain name. So for this example, I am just marking it as payment service dot, you can see that namespace. Now let's say my namespace was HC and SVC, right? And something like that. So this is a standard format. So if you provide this destination host, then what happens is that when you are running this experiment, it will only go and block the traffic to this particular destination host. So it is not a black hole. It is, so this is more of a scenario where you are breaking the network between different dependencies, right? So you are breaking the traffic from front end to the payment service. Okay. So that is how this scenario will work. Now, uh, going back, now instead of doing a network loss, now let's say if you would like to go and do some delays, right? What you can do here is you can go to your account settings, Chaos Hub, Kubernetes, right? And instead of creating a network loss, you can select a, so let me see, network latency. You can select an experiment called pod network latency. As the name suggests, this will also block an egress call. This will also delay an egress call. So you can fix this and ask users to provide runtime inputs. Tune faults, same thing. Now, network latency is something which you can allow users to decide. So you can make this as runtime input. So a user can decide whether they want to delay the response or they want to delay the request, the egress request by 10 seconds or 5 seconds, something like that. And the same concept here, pod affected percentage should be 100. The concept remains the same. If you want to delay to a particular service, then you should provide the fully qualified domain name. Or if you have an IP, you can provide the destination IP also, right? Or you can provide a destination host name also, whether it is something you are interacting outside your Kubernetes cluster also. So whatever you provide, it will block only for that particular dependency. So that is how a network latency experiment is set up. Now, going back to the other use case scenario, where let's say you want to target or block the responses or traffic to a service which is not sitting in your Kubernetes cluster. Now, the third party encryption service is sitting outside your Kubernetes cluster. And your Kubernetes cluster front end service is making a downstream API call. Now, the use case here is I would like to block the response coming from this third party encryption service just to see if I do not receive a response, how does my application behave? Do I have a failover logic? Okay. So to target those scenarios, we have another set of experiments called API experiments. Okay. So for that, what you can do here is you can go to account settings, go to your Chaos Hubs, go to Kubernetes, right? You can create your own hub. So since I've created Kubernetes, that is why I'm saying Kubernetes. I can now say that downstream API egress network loss. And in the description, I can say that API loss I am doing through pod API block. This is the experiment name. Okay. We'll talk about different parameters. Here I can select pod API block and I can go to the target application. I can fix the deployment, make rest of the parameters as runtime input so that it can be generic so that we can templatize it. We can go to tune faults, uh, put this parameter as 200 seconds or 180 seconds because this is the right time when you will be seeing the impact. Target service port, we will talk about it later. Okay. So first, we are only focusing on egress scenario. Now there is a proxy port, and by default the proxy port is 20,000. You do not have to change that. That is how Harness works behind the scene, where it launches a proxy server on 20,000 port and it blocks the API calls. Okay. Network interface by default is also ETH0. Now there is something called path filter. Now this is an optional field. Why this field makes more sense? Now let's go back to our UX. As you can see that this encryption service, I am making three calls, one for encryption, one for decryption, one for checking some address. Now, if I want to block a specific call, how can I do that? Right? So that is where the path filter comes handy. Now, let's say I only want to block the response when I am doing the encryption. Okay. So I can provide a path filter. Now this can be a substring. Let's say if you have a very long path, you can just provide something which is unique and we will take it as a substring and will work. Okay. Now the data direction. Now what does data direction means? Now the data is flowing here is since front end is making an egress call. So this is request and then this third party would be providing some response, right? So for data direction, what you can have here is since we want to block the response from this third party, I can put it as response. Okay. Now, by default, we are blocking request. So it is up to you whether you want to block request, response, or you can do both. Both means nor the request nor the response. Okay. Now, to go further into this, if we go to our developer docs and go to pod API block, you can see the data direction. Either it is request or response, right? So you can provide either request or response here. Now for our use case, now let's say I want to block the response. Now what does transaction percentage mean? Do I have to block everything? My use case is yes, I want to block all the calls. So I will put it as 100. This is a best practice here. There are also header filters, optional parameters. You can also provide method also. So let's say if you are doing a get call or a put call and you only want to block a get call, then you can provide get. If you want to block a put call, you can provide put. Post call, post, right? So you can find all the details here. So just going back to the documentation, just to show you an example of path filter. See, we are blocking a status path, right? Similarly, you can provide any other path also, and it will be a substring. We also support substring here. Now, going back to there is a support for query params. Let's say if you want to block it for a particular query param, you can provide key equals value, right? That is also present in the documentation. Now, coming back to the important parameters. Uh, Service direction. Now service direction by default it is ingress. Now since we are doing an egress call, so we have to write egress here. Okay. Pod affected percentage. I want to affect all the replicas. So I'll give 100% here, right? Then the other parameter which is important for egress scenario here is going back to the network diagram. For third-party encryption service, I'm doing a call over 443. Okay. So destination port is an important parameter for egress call. I can provide 443 here. right? And then we have this parameter of destination host or destination IP. Now, this is where the concept remains the same. If you do not provide destination host, then it will block all the host where the traffic is going over 443, which are on this path, which is encryption path. Okay. But so that is up to you. If you want to provide destination host, you can provide. But if you do not want to provide destination host, then also it makes sense because now your blast radius is more. Because let's say if there is another host, right? You will block the traffic for that host also because you are not providing the host name here. Okay. However, what you can also do here is now, as you can see, this front end is also talking to a promotion service as well, right? Now, what I would like to do here is I want to block the traffic, let's say to promotion service also at the same time. Now, if you want to do that, what you can do here is you can uh, uh, as you can see, there is a path filter option is there. You can provide you can remove the path filter option. That means it will block the traffic for all the path. So just going back to an example, there are three paths here: encryption, decryption, address, monthly, weekly, quarterly. Now, if I want to block traffic for all the path, doesn't matter. Then there is no need to provide these parameters, but these are optional parameters. If you want to do a specific tuning, you can do that. And what I can do here is I can provide the destination host. So let's say in this example, my destination host is fastencryption.com. So I will write fastencryption.com. That means block the response from this host and which is coming from this port, right? Now, if I also want to block from another port or another host, then what I can do here is what is the host name for promotion service? It is livepromotions.com. So I can say that livepromotions.com. Now, is this host using a different destination port? Okay, if that is the case, then I can provide another destination port. And in this case here, it would be 80. So I can say that block the traffic where destination host is encryption, promotion, and destination port is 443 or 80. Now going back to the documentation and showing you the destination port options. Comma separated list of the destination service or host port for which egress traffic should be affected. So as you can see, by using comma, I can provide this information. Okay. Now, this is what we have for the egress scenarios. So in the egress scenarios, to reconvey what is important, of course, target application. You will provide your namespace, deployment name, and then you will go to tune faults. You will provide data directions, which means whether you want to block request or response. Transaction percentage should be 100. And then you have an option for path filter if you want to block for a specific path, whether it is encryption, let's say, let's say it is slash encryption, right? So if you want to block for a specific path, you can provide that. The other important parameter is service direction. Service direction should be egress. Destination host is optional. If you provide, then it is very specific. The blast radius is controlled. So our recommendation is always provide destination host to control your blast radius when you are testing. Start small and then further increase the blast radius. The parameter which is important or mandatory here is destination port. Destination port is required if it is an egress scenario, and you can provide a comma separated list of ports also. Pod affected percentage, best practice is 100 because you would like to affect all the replicas. So that is how you target an egress scenario. What does egress mean? Where the front end is sending a request to third party encryption. Now let's say that this front end also would be receiving some request from outside world or inside world. And now if you want to block ingress traffic, then how do you do that? Right? So for that, we will create another template, and I will go to the Chaos Hub, Kubernetes, experiment template. Now let's say that I want to block ingress scenarios. I can select this, click here, add a fault template. Again, I will select pod API block. Perfect. We'll go and fix some of the things and make other things as user defined. So namespace, workload name, tune fault. Now we talked about this target service port, and this target service port is actually the port of your target application. So in this case, it is front end. Just to give you an example, so this is the target application, right? And this is what that port is. So now let's say that if you want to block all the traffic, which is your container port, let's say is 8080. That means you want to block all the ingress traffic which is coming to the port 8080, right? And that is how you configure an ingress scenario, and rest of the parameters are not required. And the service direction by default it is ingress, right? So for an ingress scenario, you don't even have to fill that. Pod affected percentage, yes, you can fill it. And our recommendation would be you do that, because then it affects all the replica and the transaction percentage, right? And the same concept goes here, whether you want to block a request or you want to block the response. So of course you would like to block the request here because it is an ingress and you are receiving the request. So that is how you can tune an ingress scenario, a network loss. Now, having said that, if I go to the same use case again, rather than doing a network loss, if I want to do some delays on a specific path, on a specific port, how can I do that? Right? So we saw that you can use pod network loss and pod network latency. Pod network latency can help you do the delays. However, if you want to do delays for a specific path, that means there should be an option for you to provide some path parameter. For those kind of scenarios, we have API latency experiments, same concept, right? So you can go to the Chaos Hubs, create one more template, and now this time you can say that I want to do API latency, right? Let's say for egress scenarios. I click next, and then I go to the fault template. In the fault template, I will select pod API latency. So we have pod network latency. The pod network latency doesn't give you an option to provide path parameters. It is always for egress scenario, but pod API latency gives you more configuration. You can do an ingress, you can do an egress, plus you can also specify the path parameter. So that is the advantage and difference here. So you can select this experiment, same concept, fix something, and then make rest of the parameters as a runtime input, go to the tune fault. You can fix the duration, latency, you can make it as runtime, so user can provide their latency. Now, since it is an egress scenario, target service port is not required. What is required? Destination port. You can provide destination port, pod affected percentage, you can do 100. Service direction should be egress, right? And what you want to block is that path filter. Now let's say you want to delay the response only for the encryption path. You can provide that. Transaction percentage should be 100, right? And now the same concept, destination host. If you do not provide destination host, then it will block or it will delay the traffic for all the hosts which are part of this path filter. Okay. And if the request is coming for 443, so your blast radius is more. But if you provide a host, let's say live.encryption.com, then only it will delay for this destination host. where the request is coming, response is coming from 443, and where the response is coming from 443, pod affected percentage, target containers, and you can see that rest of the parameters remain same, and that is how you can go ahead and configure these parameters. So this is what we have for today's tutorial. We covered about network experiments. We took an example of sample application, how calls are happening and how you should be able to configure that. So, so this is what we have for today, and see you in our next sessions, and happy learning.